So good afternoon. This is a technical level 300 to 400 deep dive on video interoperability with Skype for Business. So just show of hands, how many of you here were at Microsoft Ignite in Chicago last month? Nathan, other Nathan. So that's pretty good. So in that session, a colleague of mine, Jeff Schertz, he presented on the same topic. The only difference that he had like 90 minutes and I have 30. So this is going to be a compressed version of it. So just highlighting some of the key points that I think important stuff that you should know. So I'm Brennon Kwok and I'm based out of Singapore office. So happy to be in Sydney. A bit cold here, but it's nice. So agenda is what's new in Skype for Business is from the video perspective, and also go straight into what are the options if you're already running a video conferencing system in your room. And how do you going to interoperate with that? We'll talk a bit about the new VIS role in Skype for Business as well, and it's going to be all about Cisco Interop. So a bit strange, like Polycom guy talking about Cisco Interop for Microsoft, but it's okay. It's part of the product. So first off, what's new in Skype for Business is essentially think of Skype for Business from a video perspective as all of the Lync enterprise features, but with a Skype for Business user interface. So you've got the ability to do all the video calls, conferencing, IM presence and what have you in the Skype for Business client, as you do in Lync, but now using all the Skype icons. It's circular. It's a consistent experience. So if you're using this consumer Skype, then using the Skype for Business interface is pretty much, very, very familiar already. From the architecture perspective, because Skype for Business really builds on top of what Lync Server 2013 had, so it's pretty much the same. So H264 SVC is still the preferred codec when negotiating video calls. RTV is still available for backward compatibility if Lync 2010 clients. H264 SBC will support multiple resolution streams with temporal scaling. Talk a bit about that in the next few slides. And the Lync AVMCU itself supports up to 5 video streams, as you can see in the gallery view, and a panoramic stream if you have the roundtable connected and sending video. And of course, it does 1080p 30 frames, for Skype for Business, compared to just in the old days in Lync 2010 where you had just 720p. So architectural-wise, it's about the same as Lync 2013. There are some new things, so we'll talk a bit about it. But essentially, when we say H264 SVC multistream, what we mean is a couple of things, right? First of all, you've got multiple frame rates within a single video stream. So if you look at the diagram here, you see 2 endpoints in the call. The endpoint on the left is sending the endpoint on the right is the laptop that's requesting for a 30 frames per second video stream. So the endpoint on the left that's sending it is encoding that stream in two frame rates, 15 frames per second in 2 different frame rate layers. Okay, why is it doing so? And that's the reason why. So if you now turn on someone joins the same meeting using a tablet and is asking for 15 frames per second, right? The sending client doesn't have to encode additional layer. It just uses the existing 15 frames plus 15 frames layer and then sends half of it to the tablet, right? So it cuts down on the need to encode additional streams, and it's a saving on CPU on the sending client side. All right, because it's only sending only 2 frame rates per layer per stream. So if now a mobile device was to join and it's asking for 7.5 frames per second, the sending client will have to encode another frame rate, which is 7.5 frames per second. So in this way, the AVMCU is actually just doing relay of those on what's needed to the end client, the receiving client. So this is really much of the receiving client requesting for what frame rate that they want, and then the sending client then trying to meet those requirements and sending the correct frame rates over there. The good thing about this is that there's a lot of intelligence built in. So now, if you look at if the laptop on the right was to drop off the call, right? The sending client will no longer need to send the two 15 frames per second. It will just need to send a single stream that has two 7.5 frame rates. And then it will just combine the two to send the 15 frames to the tablet, and then just send the 7.5 frames to the mobile device. So this is a lot of intelligence that Microsoft has built in to the Skype for Business server and the client to optimize both the network and also the CPU usage. So if you think about multiple resolutions, again, it's very similar. So I have a client requesting for 30 frames, 360p. It sends that. Another client comes in at 720p. It sends that. And the tablet comes, mobile device comes in at 180p. It sends that as well. It's important to note that for resolutions, each stream is independent and includes the entire payload. Okay. So just moving along. This is also pretty much the same as in Lync 2013. So if you look at the SIP invite in the SDP packet, you'll see all of the Lync client will just advertise all of the audio and video capabilities that it can provide. So in order of preference, you see that from an audio perspective, 117, which is G722 at 8 kilohertz, actually 16 kilohertz wideband, is going to be sent. That's the preferred codec. And on the audio codec, it's actually 122, which is essentially it's H264 UC, which is Microsoft's version of H264 SVC codec. So what are the interoperability options? Having understood a bit of background on the codecs and the capabilities, what are the options? So one of the things that you hear a lot about in the next couple of slides is the concept of VTC. So VTC is essentially referring to a room video conferencing system. So if you have meeting rooms that have been equipped with video conferencing systems, this is what a VTC is. So VTCs can range from small, fixed cameras to large, systems with multiple microphones and all. And this is to cater for the different room sizes. So you can have a small huddle room with just a small camera, single microphone, to a large boardroom with multiple ceiling microphones and even multiple cameras. VTCs usually support a standard-based protocol like SIP or H323. And so we have a couple of types of VTCs, essentially two classes or three classes, if you will. So Lync compatible VTCs are those that have support native registration directly to Lync or Skype for Business. So example of this will be the Polycom group series of VTCs. Legacy VTCs are those that do not have any native Lync capability or Skype for Business capability, and usually need to interoperate with Lync or Skype for Business through a gateway. And finally, the Lync room system itself is essentially not really a VDC. It is a room system, but it's not classified as a VDC because it's natively running the Lync Windows and Lync client inside it. So for example, the Polycom CX8000, that's a Lync room system or Skype for Business room system, and that essentially is a room system, but not really a VDC because it essentially is a Lync environment. So having said that, why do we need to interop, in the video world? Because a lot of organizations think that, okay, so Lync's Skype for Business supports SIP, Skype for Business talks H264 AVC. Why do we need to interop? Can't they just talk to each other just natively? Well, it's not all the same, right? So AVC is not all, the way it's implemented in Microsoft is slightly different from what other vendors have implemented it. So if you look at itself, the SIP protocol itself, you see Microsoft-specific extensions into the protocol. And if you look at the session description protocol, you see itself that a Lync 2010 or Lync 2013 client will advertise things like dash RTVC1 and X dash H264 UC. And this is different from what a legacy, will advertise, a legacy VDC will advertise in terms of just, for example, 264. So you can see that while it is 264 under the umbrella, there are extensions that make it not natively, be able to communicate. So that's why there's need for interop scenarios. So we're going to talk about the 4 different interop scenarios that you have in that Skype for Business offers. Okay, so the first one is native room, right? So native room is where you have, like what we wanted to mention, essentially a VTC that can register directly to the Skype for Business environment. So it's native, there's no intermediary solution required, and the experience is pretty good. Essentially, you get bidirectional presence. You can drag and drop these systems into your AVMCU call. So from a Skype for Business client, you can just drag one of these VTCs into the call. The VTC can receive up to 5 video streams from the AVMCU, so you get a kind of a gallery view experience. And of course, you can have the calendar, to click to join. So most of these VDCs would have, if they have a calendaring function, they'll be able to log on to Exchange and get the meeting invitation, and you can able to join the meeting from the room itself. So this is a native room integration model. I would say it was the best and easiest way of integrating a room system VDC with Skype for Business. But then again, not everyone manufactures such a system. So you want to take a look at an example of this. This is what we provide in Polycom. We have the group series of room system. This is what we call, it belongs to the first model, which is essentially the compatible VDC. So all of the Lync interoperability is native. Exchange registration is there. It supports the Lync SBC codec. So all of the native Lync conferencing features are there. So again, again, this system also supports, because it's a room system, so it supports quite a number of peripheral expansion options. So we have things like eagle eye, acoustic cameras, eagle eye producers, eagle eye directors, multiple ceiling mics, and so on and so forth. So it's pretty kind of a very good experience if you have a large room and you want to integrate that with Skype for Business. This is probably the easiest and best way to go about it. And if you want to have a look at what this looks like, our booth is just right outside at the activity area. So we also have the Polycom CX8000 room system. So this is actually what I mentioned earlier, that was not classified as a VTC, because natively it is running Lync inside. It's running Windows embedded, and it's running Lync, and it will be updated to Skype for Business in the coming months. So again, this is another option. We pair this system essentially with a roundtable device known as a CX5500 or CX5100. So these systems essentially provide a round panoramic view of the room. So it's fully compatible with Skype for Business. So you can just plug it into a Skype for Business client PC, a laptop, and use it with Office 365, or you can plug it into a Lync room system, which is for example, the Polycom CX8000. Again, we have some of these on display at our booth, so just drop by and have a look. The second model of interoperability is essentially using gateways. And this is for VTCs that do not have any native Lync registration capability. So the VDC will have to register to some form of gateway which is native to itself. For example, a Cisco endpoint would register to COCM, for example. And so on this scenario, usually you would have to have a SIP trunk between the Skype for Business server and the VTC gateway. And essentially, you often need transcoding. And later on, I'll talk about the new video interop server, or VIS role in Skype for Business, which is essentially simplifying some of these things that you need to do. Previously, you had to purchase additional hardware to interoperate with those gateway. But now Microsoft has brought that into the Lync Skype for Business product itself. So if I have time, I've got 12 minutes, so I'll talk about VIS. If I'm not, I'll just skip it altogether and just maybe watch the Ignite sessions videos. So the third option, we do have some scenarios where solution providers that provide a third-party MCU. So this is like a multi-point control unit, and everybody dials into the system, right? This system is provided by a third party. It can be hosted in the cloud, or it can be put in on-premise. And essentially everybody, including the Lync clients, the Skype for Business clients, and the VDCs, they all call into the MCU, right? So we have an example of this solution outside in the booth as well. You can find out from them. Essentially, this model can be useful in certain situations, but it does have a little bit of a user inconsistency in terms of the user experience, because instead of using the Lync AVMCU, everybody just call it into the third-party MCU. So some of the modalities may not be available in those experiences. So, and on top of that, you do have a bit of redundancy. So you have the Skype for Business AVMCU, you're just not using it at all, because everyone is just using the third-party MCU, and that's the main engine behind all of these calls. So again, it's out there. We do have people using it, but you got to consider carefully some of the limitations as well. So how do you get, if you have a case where you have VDCs and you want to use of both the third-party MCU and the Skype for Business MCU. So the best of both worlds is to actually have the last and interoperability model to make use of the fourth one, which is MCU cascading. This is a situation where the VDC would continue to speak natively to its own MCU or gateway, and it will then be able to cascade the system, the technology will be able to cascade those rooms with the Lync clients on the Skype for Business side. So the beauty about this is that you've got the best of both worlds. You're making of both resources, right? So it's no redundancy here. At the same time, all of the Skype for Business users are having a consistent experience. So they're using the native Lync way to join the meetings, they schedule the meetings, they drag and drop, and everything happens just as they would, Lync on the Lync side. They don't even know that, the VTC on the other side is actually using a technology to cascade into the AVMCU itself. So there's not a lot of people that provide this particular model where all modalities are bidirectional, including content sharing. So Polycom is one of those first few in the industry that provides this using something called RealConnect. RealConnect is our technology that provides that MCU cascade experience. So in this scenario, you have your Lync clients or your Skype for Business clients scheduling those meetings using Outlook just as they would, no different, no change whatsoever. They schedule that meeting, and all of their Lync clients and Skype for Business clients will join to the meeting. And then you have those room systems that also receive the invitation, right? And so all they need to do is just click to join. And what happens is on the back end is that it would then initiate a cascade between the Polycom Real Presence platform MCU to the AVMCU. All that happens behind the scenes. The end user doesn't even know it happens so quickly, they don't even know that it's happening, and all they get is a consistent experience. So the Lync users, the Skype for Business users can see the VTC users, and the VTC users can see the Skype for Business users. You get all the 5 streams into the call, and all of the Lync users can also share content with the VTC itself. So it's, again, like I said, bidirectional content sharing. So from the Lync side, you can share content, and that will be converted by our platform into the standard protocol to be displayed on our VTC and vice versa. The VTC sends content over, it will be transcoded, it will be converted into the RDP protocol and be shown on the Lync side. So again, this model is the ideal because you get native Lync experience that's preserved. They don't have to learn anything new. You get both all modalities in a bidirectional sense. So the good news also is that this thing works with almost any industry standard 323 or SIP VTC. So you may have an older VTC that does not have any Lync capability. If you put the RealConnect system in place, you can have those modalities in there. So here's an example. We have a Cisco C20 actually in the call and having the same experience. So the Lync client is receiving the content from the Cisco endpoint. Cisco endpoint is also receiving content from the Lync client. We're the only ones that can enable this scenario or this experience using our RealConnect technology. So again, if you want to see a demo of this, it's available at our booth outside. So this is just another diagram that shows you the RealConnect in a multi-partner scenario. So we even support the immersive telepresence rooms that Cisco might have. So CTS rooms can go into the call, and the active segment will show up on the Lync client itself. And at the same time, people joining from Jabber, or mobile clients can also be part of the meeting as well. So so this is the technology. So 7 minutes. So I've got move on to the bit of the last bit of it, which is essentially the VIS role or the VIS server role in Skype for Business server. This is video interop server, and it's a new role that has been introduced into Skype for Business server 2015. And what it does is it allows both peer-to-peer and conference calls with legacy VTC users, right? So not the Lync capable VTCs like the Polycom Group series. We don't use this role. But if you have a legacy room system which is not Lync capable, then you can make use of the new VIS server role. So what it does is that the VTC user can call a Skype for Business user client or Lync client directly, and it does this by just calling the telephone number of the Lync user or Skype for Business user, and the video will be established between the two. It can also join a Lync conference call, and it does this by calling the conferencing auto attendant number and then entering the conference ID. And then the system will then join the VTC into the AVMCU call. What it does provide is just a single stream at a specific resolution and frame rate from the VDC into the Skype for Business call. So so essentially it's a video gateway. Right? You have a SIP trunk that's being established between the video gateway. In this case, it's as you see later on, it will be CUCM, and that has a SIP trunk into the Skype for Business VIS server role. And the room system, the VDC room system, has to be continued to register back to their own video gateway, and that's how the architecture is being made. But from a media perspective, then the VDC would send media directly to, the Skype for Business VIS server role, and you see that later on in some of the diagrams. But essentially, there's only a handful of endpoints that Microsoft has tested, and I'll show you that in the next couple of slides. But a couple of things to note that while this is great, it provides basic calling functions, there are a number of limitations that you need to be aware of, and this is actually because it's just released like a first version of it being released in Skype for Business. It does not provide some of the key things that I talked about earlier on, like presence, content sharing, and also CCP support. So which means that you can't drag and drop these VDCs into a meeting, a Lync meeting like you can a Polycom system. You can't see presence on either side. You can't do content sharing. So these are all the key limitations that it has. So I don't need to go through all of them, but you get the idea. So if it meets your requirements, then fine. Just use it. It's free. It's part of Skype for Business. Just implement, deploy it, and you can get those basic functionality. But if you're looking for some of the functionality that's in this slide, which is not provided by VIS, then I would suggest you look for other solutions such as the Polycom RealConnect. Another important thing here is that it doesn't support Lync 2010 clients because the VIS role does not do H264 to RTV encoding. So how does it work? It actually does transcoding. Okay, so it transcodes video which is H264 AVC from the VTC side at a specific frame rate, and it will then encode them into one or more frame rates and resolutions on the Skype for Business side. Because you have, Skype for Business side, you can have a laptop joining, you can have a mobile device joining, and these could be requesting for different resolutions, right? And because the VDC is only capable of sending a single resolution at a single frame rate to the VIS server, it then needs to transcode those into multiple resolutions and frame rates to be able to meet the requirements of the Skype for Business clients. So, and the direction is actually one way, right? So it's important to note that the calling capability is VDC calls VIS and then it goes into Skype. You cannot do it the other way around. So it is a one-way calling from VDC, like I said, either using the telephone number of the Skype for Business user for a peer-to-peer call, or calling the conferencing number and then entering the conference ID for a multi-party call. Again, transcoding requires CPU resources, right? So from the documentation, essentially, it's mentioned that if you follow the Microsoft recommended specifications for a VIS server, a single VIS server will support up to 16 VDCs transcoded, right? So assuming that a 720p stream is being transcoded into 3 separate streams of 720, 360, and 180, then we can support up to 16. So if you have more than that, you have to have multiple VIS servers. So VIS server role is also, I forgot to mention it, it cannot be co-located with your front-end server. It has to be a separate pool that you need to set up. And I'll show you some of the pictures later on in the topology builder. You can turn off transcoding if you don't want to. Then what will happen is that once you turn off transcoding, then the video image requested will be the lowest common resolution to meet all of the client's requests. So if you have a mobile device going at 180p, then everyone will be getting 180p video, whether or not you're using a laptop or using a big room system. So it's not an ideal video experience, of course, but if you don't have the kind of capacity, then you have to turn it off. Currently supported gateways, Microsoft has only tested CUCM version 10.5, okay, and these are some of the room systems that Cisco has provided. As you can see, it's all about Cisco here. So I mentioned earlier on, Polycom guy talking about Cisco Interop. Really, but that is the fact. So currently, these are the only endpoints that are supported with the VIS role. And the VDC system has to be running TC7 or higher. These are currently tested. I'm not saying that, it's not going to say that if you have other models, it's not going to work. but Microsoft has only tested these models and will only officially support these models that's on this list. Of course, I think Microsoft, as they go on, they will test more and they will add it to the list as well. So, so in terms of coexistence, so if you have a Lync 2013 server pool, can it make use of VIS? Yes, it can. You do need to have a Skype for Business front-end server to be able to set up and deploy a video interop server. But once you've got that, then you can have your clients still hosted on your Lync 2013 server, and those can make use of the VIS server role using the VIS server to join the call as well. Okay, so what's important when you have even older clients? So Lync 2010, like I mentioned, is not supported from a VIS point of view because the VIS does not transcode any RTV video into AVC, H264 AVC. So here you have a diagram where you have a meeting and everyone is using Skype for Business client. It's fine, everyone's working. So the mobile client is actually sending SVC as well. Okay, so that's fine that the VTC can see that mobile user. But if you have, the moment a Lync 2010 client joins in, then the AVMC will instruct the mobile client to send just RTV. So what happens is that the RTV, the mobile client will drop off from the video on the VTC side. The Lync 2010 clients will drop off from video on the VTC side as well. So that means the VTC will not be able to see the Lync 2010 client nor the mobile clients. So time is up. I have to, I just have one or two slides to finish up. So VIS does support resiliency. So it does support multiple pools. So if you have, for example, VIS pool 1 and VIS pool 2, you set up multiple trunks from your COCM into the different pools. And COCM will just try different trunks. If one trunk doesn't work, it will just use the other trunk. And if you have multiple CUCM gateways, it can distribute those, VIS can distribute those calls to the different CUCM gateways using DNS records. You can also have voice and video trunks in the same gateway. So think of it as like the video trunk is like, the VIS is like a mediation server, but for video. So mediation server does audio, and VIS is the one that does video. So yeah, so this is the last slide. So resiliency-wise, it's also available on a front-end server. So it leverages the backup front-end pool in the topology builder. So if you have a front-end pool that has makes use of two front-end pools make use of VIS, the VIS is able to send option polls into once a minute to both pools. And after 5 consecutive failures, it determines that the pool is down. It will send calls to the backup pool. Okay. And the VIS also implements a 10-second timer. So if the primary pool is not responding within 10 seconds, it just starts to send calls into the backup pool as well. So I don't have time to show you the topology diagram. So anyway, I hope this has been it's been a short 30 minutes. It's quite a lot of content I tried to cover, but that's it for my session. So thanks, Nathan. Thanks,